Hi everyone, this is our first video about the CSS Pure Mathematics Exam from 2023. So we'll begin by solving the problems in section A. And here's question 1, item A. It asks us to find the center of the group S3. So let us recall what is S3. So as a set, S3 is the set of all bijections from this set here, whose elements are the numbers 1, 2, and 3 onto itself. So it's the set of all permutations of the numbers 1, 2, and 3. But in order to make it to a group, we need to introduce an operation. And the operation we introduce in this set to make it a group is the operation of composition of mappings. Now, for the center of a group, when we have a group G, the center of this group, which we denote by Z of G, is the set of all elements in the group which commute with every element in the group. So we need to find Z or Z of S3. Okay? So recall that we can represent each element in S3 as a matrix whose first row has entries 1, 2, and 3, and whose second row has entries sigma 1, sigma 2, and sigma 3. So below each number 1, 2, and 3, we put its image under sigma. So for example, the first element here in S3 is, I called it sigma 1, is just the identity mapping. It takes 1 to 1, 2 to 2, and 3 to 3. And it's interesting to see that this identity mapping is also the identity element of the group S3. Moreover, it's when we have a group, we know that the identity element of this group commutes with every element in the group. So for any group, the identity mapping is in the center. This tells us that sigma 1 is in the center of S3. So this was an easy one to check. Now we have to check the other elements, sigma 2, sigma 3, until sigma 6. So we take, for example, sigma 2 and sigma 3, and we compose sigma 2 with sigma 3 and apply it to the number 1. And we see that we obtain 2. Now we reverse the composition. We compose sigma 2, the sigma 3 with sigma 2 and apply it to the number 1, and we get 3. This tells us that sigma 2 and sigma 3 do not commute, and therefore they cannot be in the center, because elements in the center must commute with every element in the group. So we already know that sigma 2 and sigma 3 cannot be there in the center. So let's do the same process with 2 more elements, sigma 4 and sigma 5. So as before, I compose sigma 4 with sigma 5, I apply it to 1, and I see that I get the number 1. And I do the reverse composition. I compose sigma 5 with sigma 4, and I apply it to 1, and we get 3. So again, these mappings do not commute. So they cannot be in the center. So we have already checked that sigma 1 is in the center, and sigma 2, sigma 3, sigma 4, and sigma 5 are not in the center. It remains to see what happens with sigma 6. So here we have sigma 6, I take sigma 6, and for example, I take sigma 2. And if I compose sigma 2 with sigma 6 and apply it to 1, we get 2. And composing sigma 6 with sigma 2 and applying to the number 1, I get the number 3. So again, sigma 2 and sigma 6 do not commute. And then we can see that sigma 6 does not commute with every element in the group. So it cannot be in the center. So the only element in S3 which is in the center is sigma 1. So the center of S3 is the identity mapping. And that's it. So I hope you enjoyed this video. Please, if you liked it, please give me a thumbs up and subscribe to the channel. I'll be posting more videos soon. Thank you very much. Bye.